Alright, hey, this is Miss Weaver, and this is the video for section 1.1, part 1. Alright, so in section 1.1 we've got, and really just chapter 1 altogether, we've got a lot of definitions, and we're going to talk about where data comes from, and then also the difference between descriptive and inferential statistics. Over the course of the semester we're going to cover both of these levels of statistics, but we need to know what they are so we can understand when we're learning and what we're learning. And then also we're going to talk about the different types of variables in data, and actually as well as the difference of what a variable is versus what data is. So we'll look at all of these things over the course of the videos for section 1.1. All right, and of course, as we've been doing in the chapter 5 videos, these different topics will also, I'll try to make sure and point out what level of understanding. Do you just need to know that these things exist? Are there going to be things that you'll be able to use your notes or other materials in order to do or define? Is it something that I expect you to know on your own, or is it something that you really probably want to know for even past this class? So I'll try to keep up and keep that being something continuous as we go through each video. Okay, so first of all, where does data come from? Well, we get data typically from a sample, and just to be clear, we want to make sure we understand what the difference is between a population and a sample. These are words I'm sure we've all heard before, but in the context of our statistics class, there's going to be a lot of familiar words that we end up kind of not necessarily completely redefining, although that will happen as well, but just clarifying the definition. So when we talk about a population, what we really want to make sure that we are looking at as the entire group to be studied. And we need to make sure that we're careful, because this doesn't necessarily mean every single person from everywhere from all time. If I am studying or trying to figure out something about maybe the heights of young women between the ages of 18 and 24, well, if it's not a female in that age group, then they're not part of the population. So our population, in fact, it helps to define the population to be as specific as possible so that we don't end up having a lot of extra people in there who aren't, if it's people or whatever we might be studying, but we don't have a lot of extra individuals in the quote-unquote population that we aren't actually going to be using or that won't be helpful to answer our question. So our population is the entire group to be studied, and then our sample is drawn from the population. So our sample is just a subset of the population. And we will talk about all different types of sampling methods in sections 1.3 and 1.4. So I won't get into a whole bunch of how we would sample, but there are plenty of ways that we sample, many of them good ways, and a couple that we'll mention that aren't good ways. But there's our population versus our sample. All right, and then now that we hopefully understand the difference between a population and a sample, we need to know what these differences are between a parameter and a statistic. So a population is a group of people, things, objects. Sample is a subset of that population. A parameter is a numerical summary of a population. And so we do a census in the United States every 10 years. In fact, this is a census year, which a lot of this stuff that normally happens with census taking has been adjusted due to COVID-19, because we're normally they'll be going home to home and filling out surveys and books. And I actually did this in the for the 2000 census. I was part of a lady came in. She had this huge spiral bound book of all these different questions that she asked me and my roommate. I was in college at the time, and asked me and my roommate all these questions about our approximately how much do we spend on groceries each month? What's our utility bills? How much time do we do this, that, and the other? I mean, all these different questions that that she was gathering. Now, that part of census taking was actually sampling, because they didn't do that in every household. But the census attempts to go and get information on every single individual in the United States. And so if they say that the mean age or the average age of a certain, a citizen in the United States is blank, that's actually a parameter. It's a numerical summary of a population. And a statistic is same definition, basically. We're just popping in two different words. A statistic is a numerical summary of a sample. Oops. Didn't spell that right. I left my A out. Let me try that again. There we go. Now, a lot of times you may hear a parameter that's given and it be called a statistic. And I'm going to throw this into this more of an existence. Know that there is a difference in a parameter and a statistic. And especially for this class, because we'll talk about different symbols that we'll use for parameters. And let me put some of those down here for us. So some parameters that we'll see later on. And these are Greek letters. That's the Greek letter mu and the Greek letter sigma. And then one of our normal English letters, P. So these are some parameters, some symbols for parameters that we will use. Mu is the population mean, sigma is the population standard deviation, and P is the population proportion. Now, we haven't really talked about any of those words yet, and we won't until like chapter 3 or later. But I just want you to know that we do have these specific symbols that are associated with being a parameter. And then we have other symbols. We'll have one that we call X bar. And then we'll use a lowercase English alphabet S. And then we'll use this guy, which is P hat. And so these are symbols that represent statistics, different statistical values. And so we do need to be able to identify the difference between a parameter and a statistic in this class, because we will be measuring parameters using statistics and different things like that. So we need to make sure we can identify and label those numbers that we're given correctly. Out in the real world, once you're in just listening to the news or reading something online or in a paper or a magazine, or a study that you maybe for if you're in nursing or psychology and you're reading something in a peer-reviewed journal, you're going to want to know what these parameters and statistics are, but really a lot of times they just get called statistics as a broader sense of the term rather than being specifically something from a sample. Also, the majority of the time we are dealing with samples, because getting parameters takes a lot of time and money. So that's another thing to keep into consideration. All right, and then here with descriptive versus inferential statistics, this is another place where the parameter versus the statistic is used and is important. So I've got an image here that we're going to kind of work on or write on, that it's got kind of the idea of the difference between these two things. So when I have a population over here on the left-hand side, and so here I've got different men and women. Of course, they're all this teal color, so we're just going to assume that there's also other diversity within that. But I've got this population, and when I pull people from that population, then I end up, let's see here, having, that's what I call sampling. So, and again, we'll talk more about how we sample and how we would get these 6 people in this sample from our population in section 1.3 and section 1.4. But that's sampling. Once I have a sample, let's say I take the average height of these 6 people, although with men and women, that's kind of tricky because that can, height is definitely one of those things that's affected by gender. So let's instead do an IQ score. So we're going to find the average IQ of this group of people. Well, when I do that and I find all these different values that we'll talk about in chapter 3, then I'm gathering descriptive statistics. Because I'm describing my sample with some different values. And so that's what descriptive statistics deal with. And we will look at descriptive statistics a lot in chapter 3, a little bit in chapter 2 as well. So I guess let's put 2 and 3. And we'll learn how to display data, describe data numerically, describing data visually. So that's descriptive statistics will be early on. And then after we get in kind of familiar with all of that, when we get into chapter 8 and really chapter 9 and 10, then we start using statistics to then come back to say something about the population. So this is what this second arrow is. This is where we use inferential. And I hope I write small enough to... There we go. I fit it. So inferential statistics. And what we're doing there, if you think about that root word, and usually this is where I would come in and ask who knows some synonyms for infer. So if you think about that for a minute, obviously I can't hear you answer, but what does it mean to infer something? Well, to infer is to assume or to make some sort of maybe educated guess. It's not just a blind assumption. So a really good example I had a couple of times in class was I looked around the room and I was looking at the different t-shirts or whatever, hats maybe, that people were wearing. In one class, I saw somebody wearing a Vols t-shirt. And I said, I'm going to infer that you like the UT Volunteers. And I got a head nod. And in a different class, in a different location, but still working on that basis of me looking at what people were wearing, there was a young lady with a Wartburg volleyball shirt on, Wartburg High School volleyball. And I said, I'm gonna guess, I'm gonna infer, I'm gonna assume that you play volleyball at Wartburg Central High. And she nodded yes. And there was another person in the classroom that had a Red Sox t-shirt on. And I said, I'm going to guess that you like the Red Sox. Well, she shook her head no. She said no. This was at, I don't remember what store, but it's a Nike shirt and it was $5, so I got it. So I don't care anything about the Red Sox. So inferential, assuming my educated guess, I had information to use for that assumption, but I'm not always right. And that's going to be true for inferential statistics. So when we get to that, remember that we're not always 100% sure. I'm going to say chapters 8 through 10 for that inferential statistics. So we can assume things, and with information that we have from a sample, or for me, when I'm just looking at what people were wearing, we can make assumptions, and we might be right, we might be wrong. And we'll talk about those things when we get into those later chapters. But that's what it means to use inferential statistics. We use our sample and say, what can we say about this population that the sample came from?